Hello and welcome to this advanced tutorial on AutoGen. So specifically, we're going to be looking at using AutoGen to orchestrate a workflow where we can discover cheap flights from anywhere in the world. So this workflow will be able to respond to queries like this. Give me the cheapest flights from London to Tokyo on the 23rd of December, 2024, for example. It's interesting because we're going to be covering a lot of aspects here, including SQL, creating data schemas, connecting to APIs, and building a serverless database. So please stay tuned through the entire video. There's going to be a lot of information that might be useful to you. We will first cover the overall architecture of the application. We'll talk a little bit about the components themselves. We'll go into the Python code and discover how we build the end-to-end workflow with the agents. I'll talk to you also about the setup steps. And at the end, I'm going to demonstrate how the workflow works to respond to those queries that we're talking about. Before I proceed, if you haven't already, please subscribe to the channel to receive more content on large language model powered applications, artificial intelligence, and data science. Alongside this video, I have also provided a technical blog that goes through some of the key concepts covered here. That will be linked in the description to this video as soon as the blog has been published. There are also other useful resources that should be able to help you with this tutorial linked in the description to this video. I've also linked to the GitHub repository for this tutorial in the description. So please take a look at all of those resources. Hopefully you can see the workflow on screen. So there are actually three components to this. We've got the AutoGen Agentic workflow, and all of those agents are orchestrated through AutoGen and powered by large language models. We also have the Amadeus flight server, and that contains data on over 400 different airlines. So we'll be sending requests to that API and receiving data from that API, which will be later used to run some queries against. And then lastly, we've got the serverless Neon database, and this is a SQL database. We'll be transferring data from the Amadeus API and writing this to a SQL database that I have set up in Neon. Just to note, the flight data API has a generous free tier, and so does Neon. So if you do want to run this project for yourself, you will have to get set up on both. I won't be showing you how to do that. It is pretty straightforward if you follow the documentation, but it's easy enough to just sign up and get your API keys for the Amadeus flight data API and also get an instance on Neon so that you can follow along with this project if you want to. Great, that's it. So hopefully that's clear. We have three main components. We have the agent workflow, which will be orchestrated with AutoGen. We have the flight data API, which is Amadeus. And we have Neon, which is our serverless SQL database. And I'll be going through how you set up the serverless SQL database in Neon next. Before I move on to that, if you are new to AutoGen, I have previously done a video on AutoGen, and that will be in a link in the description to this video. And there should also be a link at the end of this video to direct you to that. I would recommend watching that if you haven't already, because it goes into a little bit more detail about the AutoGen framework itself. In this video, I won't be going into the details of the AutoGen framework, but just rather showing you how to build this workflow to solve the particular problem of finding cheap flights or finding fast flights, let's say. Okay, so let's just explore some of these components in a little bit more detail. We can start off by looking at the Amadeus flight server, which I will pull up on screen now. So what you have here is a flight offers database, and it's accessible via this API. And as you can see, there are a few required fields here, which are, origin location code, things like destination location code, departure date, the number of adults, for example. And then there are other fields that you can actually enter in here that will obviously help to refine that data request you're making to Amadeus. This is their test server, so this isn't production. This is like a sandpit, but like I said, there is a generous free tier available for you, and I think you get something like 1,000 API calls for free. That's going to be more than enough to run this project and experiment with it yourself. You can have a look at the type of request that you get back from Amadeus when you make a successful API call. It is quite messy. It's actually a list of dictionaries, and some of those are nested, and you've got some lists nested within the dictionaries as well. It is very messy. So I had to actually create a data schema to work on top of this. And that's where the Neon database comes in, which I will proceed to show you next. What you're looking at on screen now is Neon. Now, when you're working through this yourself, you are going to have to set up your Neon project. And that's really straightforward to do. All you have to do is follow the documentation. And I'm not going to get into the details of the setup for Neon specifically. It is simple. But once you've set your project up, you'll see this type of interface. So you'll see this dashboard. I've called my project Flights GPT, and it doesn't matter what you call the project. However, it does matter what you call the database. So if we head into the Tables tab on the left-hand side, what you can see here is there's a database which I've called Flights Data. I would recommend that you call your database Flights Data too, and that will avoid you having to change elements of the code where Flights Data is referenced as the database. If you want to call it something else, you can. You just have to look through the code and make sure that the elements of the code where Flights Data is referenced, you change to whatever you've called your database, obviously. Great. So you can see right now, the database is in fact empty. There's nothing in here. So tables are 0. I mentioned before that I had to create a data schema, and that was off the back of the messy data that you receive once you make that API call to Amadeus. And just to show you what that looks like again, you can see it's pretty much just a list of dictionaries, all intertwined. And if you're not familiar with, as myself, I'm not very familiar with airline data. I've spent most of my career working in financial services. It was quite difficult for me to come up with this data model. It is not perfect at all, but I do have a schema that seems to work on the few cases I have tested it on. And I'll show you what that schema looks like shortly. But just to give you an idea, this is what we're dealing with when we send a request to the Amadeus server. That's what we get. And to make that more structured and to make it easier for an agent, for a large language model powered agent to query, I've created a data schema that should help the agent to make sense of what data is in there and how each bit of data or how the different elements relate to each other. Now, we want to recreate that data schema in Neon, and that's going to be really crucial. So how you do it is you'll head into the GitHub repo, which will be linked in the description of this video. And you want to find this data schema.txt file. And all you do is you'll copy that file, you copy the contents of that file, and you will head to the SQL editor in Neon, go to new query, and you will paste that in here. And then you'll run it. And it shouldn't take too long. And what you've done here is you created the data schema within Neon. And I'll show you what that looks like. So where there were no tables in here before, now there are five tables that have been created. They are empty at the minute, so there's nothing in here, but you can see the schema is there, and you can see the different variables we have within each table. Okay, so there is one other thing to take note of when you're using Neon. As I said, this is a serverless database, which means that you'll have to have the host and you'll have to connect to it remotely, right? And the way you do that, or if you're going to use the code that I will provide in the notebook, the way you're going to do that is you'll need to navigate here to SQL Alchemy. And this will provide your host, and it will also provide your password, which I'm not going to show here, but it will be visible to you if you click this I, it will show the password. And you'll need to replace those parts in the code. And I'll proceed to I'll show you where you need to make those replacements when I start walking through the code. But yeah, this is very important. You'll need to replace the host that I've referenced with your own host here, which will be available to you on your Neon dashboard, and also the password that I've referenced, and also the username as well. So obviously your username is not going to be John Adiojo. Your username is going to be whatever your account username is for your Neon instance. And that is pretty much it for Neon. Right, let's start looking at some code. Central to this code is the notebook, the Python notebook. This is Flight's tutorial notebook in the GitHub repository. It'll be there for you once you have access to that repo. There are some modules that supplement this notebook, and I will be going through those as well briefly. Before getting into the details of the code, there are some setup things here. I alluded to them in the last part of the video when I talked about the Neon server and the API keys required to access the Amadeus server. So let's just get into those really quickly. The first thing we'll look at is this file, which is the Amadeus _API YAML file. Now, it's called Amadeus _API, but essentially you're going to keep all the details here for your Amadeus to request the Amadeus API, so your Amadeus secret and your Amadeus API key. But you're also going to position your Neon details here. So I mentioned before that the Neon server has a host, which you will have to paste here. There's also a password for that server, and you will have to paste that here, the username and the database. So you are welcome to change the name of the database. However, it's probably easiest if you just keep it the same as what I've called it, which is flights_data. Hopefully that all makes sense to you for getting that part of the setup done. And let's move on to the next part, which is the configurations. So the configurations.json file is where you keep all of the configurations for the OpenAI large language models that we'll be using to power the agents. You will require an OpenAI API key, obviously, to make this work, but the models themselves, you're flexible to change. GPT 3.5 is the cheaper of the two models. It will cost you less per call. However, it is less performant, and I found that GPT 3.5 does not work anywhere near as well as GPT-4 Turbo for this particular use case. So I would advise you to use GPT-4 Turbo, which is, at the time of recording this video, GPT-4 11.06 preview. Obviously, that will change as OpenAI update their models. But yeah, you should come in here and adjust the models that you want to use as you wish, and then put your API key in as well. Make sure you put your API key in both slots here. And that is pretty much it for setting up the notebook, and you should be able to run that notebook end to end once you've made all of those necessary adjustments. Before I move on, there is one step that I didn't cover, and this is just this. There's two steps I didn't cover. So this is these bits up here, right? So you will need to change this configurations path. This is hard coded. I won't be changing this, so you'll need to change this to the directory of your configurations file, your configurations.json file. So make sure you do that before you run the notebook, and also in the update tabs.py. And you will have to change the script directory here to point to your Amadeus _API.yaml file. So just make sure you make those two changes as well before you run the notebook end to end. Otherwise, it will fall over because it will be pointing to the wrong scripts, the wrong files, all right? Now, heading back into the notebook, there are a few different parts here. So we've obviously got our utility functions, which are just putting in those configuration files and doing things such as that. But the next step is the actual functions that are going to be used within the agentic workflow. So there are specific agents that actually use these functions as tools to achieve tasks, to achieve our goal of finding cheap flights, let's say. It's worth me walking through these at a really high level to just give you an understanding of what everything is doing. So the first one is just searching the Amadeus API for flight data. So this is what we've done here. We've defined the function to do that, and there are all of the necessary parameters for that API in order to pull flight data. It's really easy to do. The function is pretty straightforward. So I would say in your own time, just have a review of this and make sure you're comfortable with the logic here and what it's doing. But essentially, we're just sending a request to the Amadeus API, and it's sending some data back in the form of, I think it's a JSON file. Let me just have a look. Anyway, in the form of a JSON, or I think it's actually technically a list of dictionaries, really. But that's what it's doing. There is another part to this function, and I will show you what that looks like now, right? So bear in mind, what we're doing here is we're requesting that data from Amadeus. So I'll jump into this update tabs.py file. So if you recall from our architecture, what we're doing is once we send that request to Amadeus and we receive the data, we're then updating our serverless Neon SQL database with that data. And this is the purpose of this file, the update tabs.py. So the update tabs.py file essentially does what it says on the tin. It updates those tables that I showed you earlier in the Neon database. So this is just by connecting to that Neon database, and then, there's some SQL code written here. This is all SQL Alchemy. Once we connect to that, once we make that connection to the Neon database, we can write that data from the Amadeus pull into the Neon database. The second tool is the Run SQL tool. So the Run SQL tool is really important because once we have that data in Neon, what we want to do is we want to be able to make queries on that data via SQL, right? And the reason we want to make queries on that data is we want to be able to answer or respond to the request from the user or the customer. This is really key. This is kind of part of the magic of the whole process, if you like, the fact that we can use large language models to generate text to SQL. That's essentially what we're doing here. So there's an agent that just specializes in that. It takes the query and there's some prompt behind it that tailors its behavior to be able to answer that query by generating a SQL query that is then executed on our Neon database and returned back to the agent workflow for other agents to work on to respond back to the user query. All right, so that's what this is doing here, and it's really simple. We're making that connection. This is all SQL Alchemy again, and then we are executing the query that will be written by an agent. So this is going to become this will become more clear as I walk through more of the code and as I demonstrate how everything works end to end. So as I do a full run of this, you'll see where all of these steps are happening. All right, so that's what that's doing. I did previously mention the first tool, which I said the first part of it extracts data from Amadeus and the second part writes to Neon. So this is where we're putting both of those things together, and that's the get flight data tool. So that's going to also be used within the agent workflow, and there is an agent that specializes in just executing those tools. So it either uses the Run SQL tool or it uses the get flight data tool, depending on where it is in the workflow. So that's what we've covered. We've covered so far the setup steps, so how to get yourself set up on this notebook, and you need to go in and make some changes to Amadeus _API.yaml file, and also which is this one here. And also we've mentioned that you probably want to just visit this configurations.json and put your own OpenAI API key in there to make sure everything is running smoothly. So before moving on to looking into some of the agent workflows, I want to really quickly cover function calls. And function calls are really important in order to get these agent workflows to work properly with tools. If you haven't used OpenAI's function calls yet, I have an article that I've written that goes into some details about how OpenAI's function calls work. You should have a read of that. And I think I also have a video on that as well. So have a look at my previous playlist and you should be able to find that video on OpenAI function calls. But essentially, this is what allows our agents to be able to help us help us execute on the tools that we've defined. It's best to just talk about a quick example to really illustrate the power of function calls, because it is a really powerful functionality that OpenAI have made available. So the get flight data function that we talked about, I already mentioned the first step of this function is to make a call to the to the Amadeus API server. Essentially, there are parameters that server takes, and that tells the server what data that we want to have returned to us. And those parameters are things like origin location code, destination location code, departure date, return date, adults, etc. So anything that is kind of related to a flight, basically, are the parameters that we're sending to the Amadeus API. Why this is really powerful is that with function calling, we can get the large language model to interpret the query that is sent from, from a user. So let's take our example. Get me the cheapest flights from Manchester to Paris on the 23rd of December. So what's really fantastic about that is the large language model can look at that query, interpret it, and decide what all of these parameters should be. So the origin location code, it needs to be the IATA code for the airport. So the large language model knows it has already programmed into it. That's one of the learned parameters oh, sorry, it's the learned knowledge of the large language model. It knows all of the IATA codes already, so it can take Paris and find the airports that are in Paris. Now, obviously, this isn't the most robust way to do it. The best way to do it would be to have a list that was dynamically updated and pull the codes from that list. But the lazy way to do it is just to let the large language model handle it. But even so, it's still brilliant. It can pull those codes in for the origin and the destination as well. It can pull the departure date in, return date, number of adults, children, and it can also, you don't have to explicitly mention these things. That's the beauty of the large language model. It can infer certain things from how you've written the query. So if you mention you have a child under you have a 14-month-old, it will infer that that's an infant and pull that in, right? And the large language model also interprets the description, so it knows exactly how to format. So it interprets the type and the description, apologies, not just the description. So it knows exactly the format that is required for each of these variables. So it's really powerful, and you'll see that in operation as I run everything through. So that's the power of function calling here, really. And, we've got one function call for getting the flight data and uploading it to the Neon server. And then there's another function call for running the SQL query against the Neon database. Right, so before going into the remainder of the code where we're going to map out the agentic workflow using AutoGen, I'd like to just talk in a bit more detail about the workflow itself. So what I've got here is a map of the agentic workflow with role descriptions of the different agents that are part of that workflow, as well as how information and data passes between them. Let's just talk through this to make sure that we understand what's happening. So the first thing here is you can see there's a customer representative. So this could be a customer or a user. I've just called it customer just for illustrative purposes. But the customer will come with a request, something like, give me the cheapest flights. I've mapped this out by saying cheapest flights to X, right? And that could be, I mentioned Paris before, but it could be anywhere in the world that you can feasibly fly to. That I've mapped out as being passed to the group chat manager. And the reason I've done it like that is because the group chat manager is the agent that orchestrates the interactions between all of the other agents. So it's important to bear this in mind. The group chat manager is really key. That's a key role here. It orchestrates the interactions between all of the other agents. Now, agent interactions happen within this context called a group chat, and this is all part of the AutoGen framework. The group chat context allows all of our agents to pass information between each other and communicate. And by the way, that's something that is pretty tricky to do in some of the other frameworks for large language models that also use agents. So things like LangChain, Haystack, Llama Index all have their own kind of version of agents. But what is tricky is getting them to interact with each other and talk to each other. That's a problem that AutoGen has solved with this group chat context and this kind of group chat manager agent. All right, so what happens, right? So we're looking for the cheapest flights and we go to the first agent, which is a data retriever. And the sole purpose of this agent is to recommend API calls, the parameters to make that API call to the Amadeus server. So if we're looking for the cheapest flight to Paris, for example, this data retriever agent would be able to take that request and, set the origin of the destination code to whatever it is for Paris, whatever airports are in Paris. Or if we're looking for flights to London, the data retriever will know, okay, there's Heathrow, there's X in London, right? So that's what the data retriever does. It sets those parameters to make the API call to the Amadeus server. So it's important to note here that the data retriever does not make the API call itself. It just sets the parameters, right? So its job is primarily interpreting the customer's request and coming up with a set of parameters. So if you think about it like an input, customer request, output, some parameters to make to the API, Amadeus API that might return data that we need to answer that request. The information is then passed to the user proxy. So the parameters are passed to the user proxy, by which the user proxy is the agent that actually, whose job is to actually execute our tools. So we talked about two tools that we defined, the get flight data function and the run SQL function. So in this case, the user proxy will be using the get flight data function. It will take the request sent by the data retriever. So it will take the parameter suggestions sent by the data retriever and use those with the get flight data function. And what that will do is it will send a request to Amadeus and then update the database. And I already showed you how that works previously. Great. So once that's done, what we have essentially is we have some data sat in Neon that is hopefully relevant to the customer request for data. All right. That is then passed on to the analyst. So the analyst is able to, well, apologies, the data isn't passed on to the analyst, but the analyst understands that the data is now available and then generates a SQL query based on the information received from the customer. So the reason the analyst understands what information is received from the customers is because it's passed to the group chat manager. So the analyst has access to that query. So what it does is it says, okay, we need the cheapest flights to Paris. I'll write a SQL query that can query the data that we have in Neon. And hopefully that should return the relevant information to answer that customer's query. So that's what the analyst is doing here. So it's not executing the query, it's just generating that query and sending it to the user proxy agent. And the user proxy agent will execute the query based on the SQL query that the analyst has generated. And it does that via the run SQL tool. And we see what that does, right? So what it does is it runs the SQL queries and then it returns the flight data back into the agent workflow. So now all of the agents have access to that flight data, which is brilliant. Okay, so we have the analyst role here pretty much mapped out. We're just creating SQL queries to answer the customer query. The user proxy role, we're just executing those tools based on what's recommended by the analyst and the data retriever. Now it's down to the travel agent. So the job of the travel agent is to generate a response to the customer query based on the data extracted by the analyst's initial SQL query, right? So, we want to find the cheapest flights. Maybe the analyst does something like, I don't know, select star, order by price, limit 1, for example, just takes the top value. And then we get that, the cheapest flight, let's say, that's passed into the group chat context. The travel agent sees that and then generates a response to the query saying the cheapest flight is at X time and it's going to cost you, let's say, 100 euros to go to Paris. Okay. So that's all the travel agent is doing. It's just taking the data and generating a response for the customer. So it doesn't go directly to the customer. It's reviewed by a senior analyst who is prompted with a bunch of review standards that the response has to meet. If it doesn't meet those standards, the senior analyst sends a message back saying, well, it's not approved, and provides feedback. And that feedback can be for any agent in this workflow. So the feedback might be that the analyst has written the query wrong and needs to rewrite the query. Feedback might be that the data retriever hasn't actually retrieved the right set of data. So we need to look at that again. And the workflow will start again from the agent that the feedback has been provided to. Okay, now I'll say this is how I've intended to code this. It doesn't work perfectly every single time. It is quite difficult to orchestrate agents in exactly the right way that you want, because there's some randomness, especially that, this orchestration is really done through prompting. So there is a little bit of randomness that does occur, but more often than not, where I've tested it, it seems that it does return some desirable results. That's not to say that in a production situation that this thing wouldn't break. I'm sure it probably would, right? So just bear that in mind. It's not perfect, but it works well enough for this demonstration, for this prototype anyway. All right. So that's the job of the senior analyst. It either provides, if the response isn't satisfactory, it will provide feedback, and the analyst or the data retriever can act on that feedback. Otherwise, it says, hey, the response is satisfactory, and returns the response back to the customer. So that is the workflow. That's the agentic workflow in a nutshell. We are using multiple agents. We're using AutoGen to orchestrate all of those agents, using the group chat context and the group chat manager to manage the interactions between those agents. And each agent in this workflow is powered by a large language model. Only the user proxy actually executes any of the tools. So only the user proxy actually runs the functions. All of the other agents just perform natural language processing tasks, whether that is kind of, text to SQL here, or whether that is determining the right API calls to make here, or, whether that's providing a response here or reviewing a response. all of the other agents are just doing natural language processing or natural language understanding tasks. That's it. So pretty simple, pretty straightforward, hopefully. I've also written about this in the technical blog, so have a read of that, and you'll have this diagram available to you there as well to digest if this was a little fast for you. Now that we've discussed the high-level workflow, we can start looking at the code and how we're using the AutoGen framework in Python to set up our multi-agent workflow. So there's a few things to consider here. In the notebook itself, I've created the multi-agent workflow, but the prompts themselves are held in a separate Python script, which is called messages.py. And the reason for this is that the prompts are quite long, as you will soon see. So I won't be going into the prompts in detail in this video. However, they will be available for you to inspect yourself in your own time or while you're following along with this video. But let's talk a little bit about how we create this agent workflow. So the first thing is to set the configurations for each agent. So there are configurations for the user proxy, and mainly it's about what functions and tools they can access for this particular project. So the user proxy gets access to all functions, whereas the data retriever only gets access to the get flight data function, and the analyst only gets access to the run SQL function. And you'll see how that works when you go through this notebook yourself. You'll see why that is the case. The next step is to actually define our agent workflows. So here, this is where I'm importing all of the different prompts from the messages.py file. And then we set up our agents. And AutoGen provides a nice API to do this. You simply determine which type of agent you want. So there are various classes of agents that you can use within AutoGen. For this project, we're only using 3 classes. We're using the user proxy agent class, which has the ability to execute functions. We're using the assistant agent, which can perform natural language tasks. And we're using the group chat manager, which can manage a group chat. And that's what we've done here. All we're doing is setting those agents up with the different configurations that we want them to have. So there's a few parameters you can play around here. So you can play around with the maximum consecutive auto replies from the user proxy. I've set this to 10, but it doesn't have to be 10. It just means that if there is, for example, if we've made a SQL query, but the SQL query ends up being wrong, then the user proxy can kind of respond to the analyst when the analyst has made a change to that and adapt it. So it gives us a bit of flexibility here. However, it will cost us more because we are querying OpenAI. We are making a request to the OpenAI API more times here. So just bear that in mind. You might want to reduce this number. However, it shouldn't get to 10 for many of the use cases that we're working with. And then there is something here called the termination message as well. So if there is a termination message, the user proxy will signal to exit the workflow, and that's what we've got in here. So all the other agents are being set up as, besides the group chat manager, all of the other agents are being set up as assistants here. So we've got an assistant agent for the data retriever, and we've got the system message here, which is the prompt. So remember the system message is the prompt, and that determines the behavior of that agent. And you'll soon see how these prompts are working when I show you the messages.py file. You've got the analyst set up, and you've also got the travel agent, the senior analyst, and then you have the user proxy, where we are registering the functions that we would like the user proxy to be able to execute. So this is what we're doing here. This is a simple way of doing that. Then we have our group chat, and our group chat, we have all of our agents participating in the group chat, as well as the max number of rounds. So this is how many turns of this group chat that we can take. And then we have the group chat manager, okay? So the group chat manager has its own system message and also its own termination message. So this basically, there are some agents that are prompted to say terminate once they are satisfied with the output that has been delivered, right? So once that terminate message has been shown in a prompt, the group chat manager will pick that up and exit the workflow. And then we can initiate a chat, and we can, ask a question here. So I'll save that for the demonstration, but I think you get the point. All we're doing here is we're setting up our agent classes, and we're setting the behavior based on this system message. And then there are obviously additional parameters that we can add here to adapt the behavior of these agents. Right, so let's have a look at the messages.py file to see what types of system messages we are creating. Now we're having a look at the messages.py file, and these contain all of the system prompts that guide the behavior of our agents in this workflow. If you've done any prompt engineering before, you'll know that it's tricky to get prompts right, to get one large language model to behave the way that you want. It becomes even more complex when you're trying to orchestrate the behavior of multiple large language model powered agents and how they interact with each other. It's vital that you make the system prompts as precise as possible and, have some kind of clarity there. And you'll see the way I've structured the system prompts in a minute to try and attempt that. Now, I'll say now, this is far from perfect. It could definitely be improved. I've probably used too many words where in some of these prompts and maybe too few in others. I'll leave that to you to have a look for yourself in detail and see where you can make the improvements. Okay, so let's look at some of the system prompts and the logic behind what I've done. So first, let's look at the user proxy. So for every prompt, I have outlined a role, and this is to give the agent a measure of self-awareness. And what I mean is not self-awareness in the human sense, but just an awareness of, okay, I'm the user proxy, and also outline some responsibilities here. So not only the agent knows who they are, but also what their responsibilities are. And I've tried to make that as clear as possible. I found it useful here to outline an objective for the user proxy because it is pretty simple. So the objective is just to ensure smooth workflow by timely execution of specified functions following the outputs from other agents. And that's key because the user proxy does execute all of our functions. So without that, then the workflow breaks. And moving on to the next agent, it is a little more complex. It's the analyst. And again, you can see the role is outlined as an analyst. I've specified some expertise here, querying a flight database based on the data schema, specify the responsibilities here. So generating precise SQL queries for user requests on flight information and so on and so forth. You can read this in more detail. The thing with the analyst that makes it a bit more complex is because it is generating SQL queries, you need to give it access, or you need to give it information about the data schema as well. So this goes back to the importance of having a data schema in the first place and being able to articulate that within the prompt. So this is what I've done here, and you can see where I have articulated this data schema. The other thing to consider is this database has some nuances. So things like segments, and there are flights that have multiple connections. I've mentioned that as a tip here because it gives the analyst some idea that, it's not going to be straightforward to just, for some long distance flights especially, you can't just sort by cheapest flight because there might be segments that aren't in that pricing table, for example. Or the flight offer table, you have to join to the segment table first to capture all of the segments. So I wanted to give it an awareness of that. And then I've given it an example and run through how you might approach solving that example with the database schema we have. The next thing is I've given it some general principles about how to structure SQL queries. So this is just a general framework. Understand the database schema, clarify the objective, analyze the SQL query, evaluate logic and conditions, performance considerations, review best practices, and iterative refinement. So that's it for the analyst. A little more complex, but the structure is broadly the same. You've got the role and responsibilities, and then there's some kind of supplementary information there to help guide that behavior to the desired state. So the next part is the system analyst. And again, we've outlined roles and responsibilities here. The system analyst is, apologies, not the system analyst. The senior analyst is a bit different here because the responsibility is obviously to curate the output of the travel agent. So we're checking for completeness and flight leg details. However, once there are different actions that a senior analyst should take or different activities that should be performed depending on the outcome of that review. So for example, if the travel agent meets all of the review criteria, then we reply with terminate, and terminate signals that we want to exit the workflow. So that's the end of the workflow and we've got our final response. However, if it doesn't, then there are some actions that we need to take. So they're along the lines of examining some of the work of the previous agent. So examining the SQL query by the analyst and examining the recommendations from the data retriever, and also the travel agent response, and identifying which agent is responsible for the issues or responsible for failing that review criteria. and then guide the workflow towards iterative improvement if necessary. And what's interesting here for the senior analyst is, as well as giving it an understanding of its own role, I've also given it the workflow, the complete end-to-end workflow. So it has some measure of understanding of where it sits in the workflow and where the other agents sit relative to each other in the workflow. So that's through this workflow graph here that I've drawn out. So if you imagine, what I'm trying to do is I'm trying to give this agent almost like a managerial oversight position where they can see a bit more of the bigger picture as well as understand some of the details there. So that's the philosophy behind that. And here's the description of the workflow. And then obviously, because the senior analyst is going to be providing feedback on SQL queries, it needs to have the same understanding of the data schema as the analyst. So the data schema is in there as well. And that's pretty much it for the senior analyst. We'll move on to some of the other roles. We've got the data retriever, which is a much less complex role. And you have your role again and your responsibilities outlined. And we've got just translate the user query into the correct arguments for the function get flight data. So that's pretty simple. And then we have the travel agent, which has its role, responsibilities outlined. You'll be given data concerning flights. You should use this to answer the user's request. You should return the full details of the journey, including stops, intermediate flights. And then lastly, this is a really important role. This is the chat manager. And the chat manager obviously orchestrates the behavior and interactions amongst all of the agents within that group chat context. So the role is outlined here as a chat manager. The responsibility is clearly stated. Your job is to guide the agents to follow this workflow. And we have the workflow outlined. So the workflow is just the workflow graph and a description of each stage. That is it for the system messages, and those messages are all going to feed back into the agent workflow that we defined in Python, and hopefully that should guide the agents to behave in the way we want them to behave to respond to user queries. Now that we have an understanding of how the AutoGen framework works and how to build this workflow, let's try it out with a few user queries that might come across. So I have outlined 3 queries ahead of time, and we'll try them out live on screen now. So the first one is, show me the cheapest flights from London to Paris, leaving on the 16th of December, 2023 and returning on the 19th of January, 2024. So I'm going to run this from the top, and I will be talking through what's happening with the agent trace here. So you can see that has entered through the chat manager. So the chat manager is orchestrating all of those interactions, and it's now happening in the group chat context. The data retriever has analyzed this query and passed the results out. So we're looking from London to Paris. It's taken the codes for that, the departure dates, the one adult, which is the default. We haven't specified if it's just one adult or not. The currency code, so it's interestingly picked out US dollars here. I'm not sure why, but we could probably specify which currency we wanted that in if we wanted to. And then we have moved on to querying the Amadeus API. So you can see here, we're passing all of those parameters into the API, and we've got a response. So that's the data response here. Now, there is a little bit of a nuance here that I will go into once the agent trace has completed. I'll step back through it and talk through the specific elements here. But for now, we are stepping through the agent trace, and we can see some SQL code here, and that has been generated, of course, by our analyst in trying to respond to the query. And it's also outlined some of the logic behind why it's generated the code as it has. And if this works out correctly, the next step should be running the SQL code, which we have. So that's been run by the user proxy, and the results are here. So we've got some data returned, which is good. And then the travel agent has interpreted that data and provided us a response. And the next flow, the senior analyst has seen that the response is adequate, so has replied with terminate, which is great. So that's the complete agent trace, and we were able to decipher which flights were the cheapest from London to Paris. And we've got an outbound flight here leaving from London Heathrow to Paris Charles de Gaulle Airport, and that is $263. And we've got departure times and arrival times here, and we've got another return flight here, leaving from Paris and landing back at London Heathrow, and we've got a price of $263. Great, and we've got a total cost for the round trip of $527. Okay, so there's a few important things to take note of here. So the first one is the data retriever. So we know that the data retriever is contacting the Amadeus server through the API and returning some data, But as you recall, we actually created the data schema, created an empty database inside Neon. So I want to show you what that actually looks like now that we have uploaded that data. So what you can see here is the data from Amadeus has been written to our Neon database. So if you recall earlier in this video, I showed you this same schema, but it was completely empty. And now you can see we have all of the flight details in here. So we have the segments, and so we have the different airports here: London Heathrow, Charles de Gaulle, London Heathrow, and there are other airports in here which I will get to discussing later. Let's just have a look at the travel pricing as well. So yeah, we mentioned the currency should be in US dollars, so we pulled the prices out in US dollars. Fare details by segment we have. So you get the picture. We have called that Amadeus server, and then we've written the data to the Neon database. So there is a small nuance here that I've created, right? So it's a small quirk of this code, and I wouldn't recommend doing it this way in production. But basically, when you're initially querying the Amadeus server, remember the query is asking for the cheapest flights from London to Paris, right? Here's the issue. London and Paris are not technically airports, but the Amadeus server can handle this, because what it does is it will give the country code or the city code for London and the city code for Paris, and it will return all of the airports that are within those codes, right? So for London, we've got Gatwick and Heathrow. For Paris, we've got Charles de Gaulle. So the server itself can operate on city codes, which is what you'd want, because people might not know the specific airport they want to leave from, but they know the city they want to leave from. Now, where that becomes difficult is that if you do not tell the agents that you want to operate off the airport codes instead of city codes, what ends up happening is they search the database for city codes. Those don't exist in the database. You leave from airports. So you fly from an airport, and you fly from airports, right? You don't fly from cities necessarily. So all of the data is in terms of city codes. And how I've solved this problem of airport codes, and how I've solved this problem is to write all of the airport codes that are pulled from the data back into the group chat. So I've returned them. So the analyst agent has access to that, and it knows, okay, when I form my SQL queries, I'm not going to form them based on the city codes that were initially put in. I'm going to form them based on the airport codes. And that's what we have here. So you can see all of the airport codes instead of the city codes, because if it had specified Paris at PAR and London LON, would have returned some blank results. Hopefully that makes sense as the first example, and you can see how that agent trace has worked. I will be providing this agent trace for you in the GitHub along with all of the other agent traces, so you can inspect them for yourselves. Okay, next, let's try something a little bit different. So instead of searching for the cheapest flights from London to Paris, let's see if we can find the fastest flights from London to Paris. So I have show me the fastest flights from London to Paris, leaving on the 16th of December 2023 and returning on the 19th of January 2024. Let's run that and see what the agent trace does. Oops, it looks like we have to take it from the top. Okay, so we have entered the agent trace and initiated by the group chat manager. And interestingly enough, we have a similar set of parameters called to the Amadeus API, but this non-stop parameter is true. So we're looking for fast flights. We don't want any stops. It's interesting that the data retriever knows to specify that, which is good. And it looks like we have executed some SQL queries here. We've actually returned some results. So you can see our analyst has suggested a SQL query. It's been executed, but we've returned some results. But the senior analyst is not happy. It lacks details about the return flight, which is true. So we have an outbound flight, but no inbound flight. Let's rerun that. So that's what's happening. We've run another SQL query to get our inbound flight, I believe. And hopefully, if this is correct, we should get a response from the travel agent. We've got both identical times. Perfect. So we have completed that agent trace. And if we step back through it, it's quite an interesting one because, yes, initially we got the correct arguments from the data retriever. We pulled our data from the Amadeus server. We have then constructed one version of the analyst constructed one version of the query that's come through, and the travel agents returned an initial response, which only included the outbound journey. The senior analyst picked up on that through quality control checks, which shows the importance of having this kind of quality control on top of these agent workflows. So you need agents that are there just simply to review. It's provided feedback. So it said proceed with these actions to ensure complete response to the user's query. So there's some feedback provided here. The analyst has taken that on board and adjusted the query. We've got the data pulled back, and now we have our flights. So we have, for your return journey from Paris to London, the fastest flight options are as followed. So we have flight number 1, Paris, 6 p.m., 1 hour and 20 minutes, and flight number 5. So we have 2 options for the return journey. It's the same price as flight number 1. Okay, so these are both identical timings and duration. And we also have our outbound flight, which is leaving from Heathrow, and duration is 1 hour and 20 minutes. Okay. And then the senior analyst is happy with that, and we hit terminate. All right, so for the last example, let's try something a little bit more complex. All right, so what we're going to do this time is we want it to show me the cheapest flights for 2 adults from London to Tokyo, leaving on the 16th of December, 2023, and returning on the 20th of May. Let's just say returning on the 20th of May, 2024. So this is more complex because this is obviously a longer distance flight. I expect there to be multiple legs here, so it needs to capture the different segments. We're also specifying 2 adults here, so that's going to introduce some complexity into the workflow. Let's have a look and see what we can do with this. So we have successfully entered the workflow. We specified 2 adults here, London, Tokyo. So we notice we've got the city codes in here. We're making that call, and we have returned some data. So the request has gone through okay to the Amadeus server, and we've returned some of that data. And as you can see, we specify city codes, but we return all of the airports, inbound and outbound, because we want the analyst to query based on those airport codes rather than the city codes, as I mentioned earlier. So because this is a more complex query, it does take the analyst a little more time to figure out what it needs to do. And you might see that because it's, if you even look at the SQL query it's generated, it's a little more complex than the previous ones. There's some logic behind why it's done what it's done. Okay, so you can see we haven't returned any results for that query. So hopefully this analyst will step back into this workflow. We've terminated it. So it appears that the query did not return any results, which suggests that there might not be any flights in our database. Specific criteria, there could be several reasons. Possibility flights are not available or entered into the database if you have specific alternative needs in mind, and I can assist you further. Okay, so that might well be the case. Let's try something else. So maybe not on that date. Maybe we can try returning after 20th of May. Let's try that and see what happens. Maybe adding a little bit more flexibility in. So we have returned some results from Amadeus. Yeah, interestingly enough, we specified after, but it seems like it's still pulling the same return date. Okay, that's fine. Just means we need a bit more intelligent prompting at the data retriever stage, or maybe an additional agent to specify some dates. We haven't returned any query results. And the analyst has tried again, but no results have been returned. So the senior analyst is actually stepping back through and analyzing and giving us some tips about why we're not returning any results. And that's interesting to state because I haven't specified that the senior analyst should do that. And maybe that is an important thing to specify, because in the last agent trace, it just went straight to the user proxy to say, oh, there are no results. Whereas maybe the analyst made some mistakes in the initial query, and we want the senior analyst to respond to that. So it seems to be doing it by accident right now. But what we'd rather have is the senior analyst specifically stepping back into the user query, stepping back into the analyst workflow if no results have been returned, and providing some guidance to help facilitate the workflow end to end. So it seems to be doing that now, but you will probably want to prompt that behavior in rather than rely on chance of that happening. So now we have actually corrected our function, and it seems to be returning some results. Hopefully we don't run out of turns. So we've got the cheapest flight for 2 adults, terminate. So apparently we have the answer, right? So we've got outbound London to Tokyo, return Tokyo to London, and we have, it's approximately 24 hours, and the total price is 2,459 euros. So it has returned a result. Again, I'm going to provide this agent trace for you, and you can check the validity of these results yourself. Just to give you comfort, I'm also going to show you Neon as well, and to show you that we are actually updating that stuff in Neon. So let's just look at the segments. So we can see this is now talking about just trying to show you where the airports are. So HND is an airport in Japan, I believe. Let's have a look. HND, Tokyo Haneda Airport. So you can see in Neon that we've actually pulled that data fresh from Amadeus. So it does overwrite the data that exists in there. I've just programmed it like that, so I don't use too many of my Neon free tier by just stacking a load of data in here. But yeah, that's pretty much it. We have managed to return a result for London to Tokyo, although not in the way expected. And again, you can, if you want to take this on for yourself, you can adapt the prompting behavior of the senior analyst so that it consistently reviews the analyst response if there is a blank response, and provides some help to the analyst to get that over the line, as it has done now. We've come to the end of the tutorial, and hopefully that was helpful to you. We covered a few things there. We covered multi-agent frameworks using AutoGen. We orchestrated multiple agents to make API calls to the Amadeus server. We also orchestrated agents to write the data from the API calls to a Neon serverless database. And we built agent workflows to be able to handle requests from users about flights, and also be able to generate SQL queries to query that data and return results based on the data we saved in Neon. So end-to-end, it's quite a complex system. There's a lot of components interacting with each other. As I mentioned before, the prompts are far from optimal, and the system as it is, it's far from perfect. So work through it yourself and see if there's anything that you can do to improve the way things are working. If you enjoyed this content, please like the video, share it, and subscribe to the channel. I'll be sharing more content on artificial intelligence, large language model powered applications, and data science. Thank you.